Hello and welcome to Physics Ka Doctor. Let us understand first what is scalar. Definition says that a physical quantity which requires magnitude alone is known as scalar. A physical quantity which requires magnitude, it is known as a scalar. Say for example, let us consider I have a product inside a box, and this product name is A, and it is having mass 10 kilogram. So here, to show its physical quantity, what I required, I just need number which is a magnitude 10 kilogram plus its unit. So these two are sufficient to show a scalar quantity. I do not need a direction. If we specifically say about scalar, so we don't need any direction. Let us consider few examples of scalar. First, it is a distance. In one of the topic, distance and displacement, we understand how it works. Say for example, Arpita, right, is asked to go to her school. Say for example, this is a place where she lived, so that is her house, and somewhere here her school, it is there located. And as per her mother's thought that she should go from home to school directly. And say, for example, this is somewhat distance where school is located at some straight distance. Fine. But she has some work at ice cream parlor, and you understand, right? What is the work? What happened? She is first visiting an ice cream parlor, and then she go to school. So here we can see there are two different possibilities. She may directly pick this way to reach her destination. So if it is a shortest one, if you see the direction, there is a shortest direction and the shortest distance, it is there. So that is known as displacement. But if she is moving with some other aspect, right? Ice cream. So here the path become a longer and that become distance. We already understand displacement and distance, what are the differences, as well as large number of examples were also solved. Right. Now, a point is that a distance we mentioned in the example as a scalar. How it is a scalar? See, distance required only total. Say for example, this is 5 kilometer and that distance is 10 kilometer. So when we talk about distance, so total 5 plus 10 is equal to 15 kilometer. She traveled, if she traveled with the ice cream parlor, then this is the distance 15 kilometer. In this case, she does not require any direction. But if she travel directly straight from home to the school, so at that time, say for example, this total distance from home to school in a straight path, 12 kilometer. So now this 12 kilometer become a displacement, and to travel with this displacement, she need a direction. She need a direction, right? So therefore, here become distance become scalar quantity where we just need a magnitude. We do not need any direction. Now let us understand second part, that is the speed. What is speed? What is speed? We already understand speed is equal to total distance travel divided by total time, or you can say time taken, right? It is taken time. So here, if you talk about speed, so we need to consider total distance. So in the case of distance, suppose she travel with this path with the parlor, so it become 15 kilometer, and in this travel, suppose you take 30-minute time. So 15 by 13, that becomes speed. That becomes speed, right? And in the case of here, distance is a scalar quantity divided by time. Time is also a scalar quantity. See, we do not require any direction to present time, and therefore time is also a scalar quantity. Therefore, scalar quantity multiply or maybe a division of scalar quantity, it gives us a scalar quantity. Therefore, speed become a speed become a scalar quantity. Third one is a mass. A human mass, say for example, human mass is 60 kilogram. 60 kilogram in the direction of vertical, in the direction of maybe towards right hand, towards left hand, or vertical, it remains 60. There isn't any change. It does not possess any directional property. If I talk about weight, yes, of course, then it is towards gravity, towards earth, but otherwise it does not possess any directional property. Therefore, mass is also a scalar quantity. Then time we already discussed, time is already a scalar quantity. Then the next is area. If you talk about area, what we need here, we need suppose length or height to measure area. Length, it is in terms of meter, and in terms of length, it is already a scalar quantity. We do not need any direction, because it is just a distance. It is just a distance. Therefore, here scalar multiplied by scalar gives a scalar. And similar case is for volume. We just need one more addition of scalar, then it gives us a scalar quantity. And similar it is for the temperature and as well as time. We do not need direction, and therefore this all become a scalar quantity. There are a few more examples. Another is energy, work, power, specific heat, charge, potential. These all are also a scalar quantity. We will see how this become a scalar quantity, because work, when you talk about work, so there are some vector quantities in the multiplication, but for that we need to understand vector multiplication in terms of dot product as well as in terms of cross product, right? Then only we'll understand that how this all items are a scalar quantity. One more thing is that a scalar quantity can be added, or you can say subtracted, or multiplication. This all things can be done with the use of simple algebra that we understand, that we already learned so many times, right? So no special learning is required for the scalar quantity. It is, we have been studying this one. Now second one, that is a vector quantity. So what it present, that a physical quantity which requires magnitude. It was already there in the scalar also, right? Here in terms of magnitude, plus we need a particular direction. Here we need magnitude plus a direction. If we take the similar example, if she take a path in a particular direction directly straight towards a school at a particular direction in the 12-kilometer distance, right? A shortest path if she is taking, that means that become vector. That become vector. And this is why displacement is a vector. Displacement is a vector. We have few more examples for that vector. Let us understand one by one. So displacement is understood that it required magnitude, what distance we are traveling and in which direction the distance are traveled, right? So vector, it is requiring two quantity, magnitude as well as direction. Now what is velocity? What is velocity? So velocity is equal to displacement divided by total time, divided by time taken. In the case of speed, it was a distance divided by time. Here, it is a displacement divided by time. And we know that displacement is a vector quantity and the time is a scalar quantity. If multiplication of vector with a scalar or maybe vector division by scalar, so ultimately we will have a vector quantity. Remember this, right? Vector multiplied by a scalar quantity, it always gives us a vector quantity. We need direction in terms of velocity also. Therefore, velocity become a scalar quantity. Scalar? Is it scalar? No, it's not a scalar. It is a vector quantity. Then next is acceleration. What is acceleration? Acceleration, we know that acceleration is equal to velocity divided by time. So what is velocity? Velocity we already seen. It's a vector quantity. Time is a scalar quantity. So acceleration become vector quantity. Therefore, acceleration become vector quantity. Remember that word. The next is a momentum. What is momentum? Momentum is equal to mass multiplied by velocity. Mass, we have seen mass, it is here. Mass is a scalar quantity and the velocity we already proved. It's a vector quantity. So therefore, vector multiplied by scalar, that gives us vector quantity. That's where momentum become a vector quantity. Next is force. Next is force. What is force? Force is equal to mass multiplied by acceleration. We know from the Newton's law. What about mass? Again, it's a mass. It's a scalar quantity. What about acceleration? It's a vector quantity. So ultimately, force become vector quantity. And similar, a brother of force, it become weight, mass multiplied by gravitational acceleration. So G and A both are brothers, and therefore W become vector. Right. Similar, you can have electric field, magnetic field, etc. Right. I simply suggested you, why don't you solve this remaining quantity? Why these are in the vector group, and comment in the section below.